start, and I will start your lecture. Okay, our lecture today is 3.3, which is derivatives. Really difficult to deal. Of trigonometric functions. I'll try to show you like one or two proof for trigonometric functions. Then the rest, I'll just give you the formulas, but those of you that you like really to see all the proof, you can practice by yourself at home. It's not a difficult proof. I'll start with the proof of what is the derivative of a function sine x. If they give me a function sine x, how to know what is the derivative of sine x?
Oh, Professor, you got a question in chat.
I have a question. Let me see. At the same time, I have to see chat also. Okay, chat. Two questions. The first one is, should we redo our test? No. The problems that you solved, all of them is correct. The only two problem, number 2, number 5, it's a technical problem. I sent also an email yesterday that I'll give you full points for those two problems. And no need to redo the test, right? Those of you that you are done with the test, you are done. Even those of you that you are not done with the test yet, like I saw like 8 people or 9 people, they didn't finish the test yet. Finish the test. Today is the last day for the test, which is Friday. Try to finish your test. And don't worry about those two problems. Think like your test has 8 problems, right? And solve it, please. The other question is, okay, check the chat. Yes, sometimes when I'm sharing my screen, I'm more focusing on the whiteboard for you to write. Yeah, but if I want to see the chat, what you are asking me, I have to close the share screen and go and see the chat. I will do this. I'll check your chat also. The main question was to redo the test. No, do not. Please do not redo the test. You are okay with your test. I'll add you points. Okay, let's start with this lecture. Let me graph first the graph of sine x. For example, if they give me a function f of x equals sine x, really kind of tricky. I will graph sine x for you, right? F of x equals sine x. My pen is even not working. Now, f of x equals, oh my God, sine x. Let me graph show to you the graph of sine x if you remember from trigonometry. The period for the sine is 2 pi, right? Let's put here 2 pi. Here definitely will be pi. Here definitely will be 3 pi over 2. And here will be pi over 2. I'll just graph the positive side. The graph of sine starts from 0 and the range for the sine is 1 and -1. It starts from 0, goes up to 1, then it goes down to pi. At pi, it becomes again 0. Then it goes down to 3 pi over 2 and comes up back to 2 pi. Now, in this graph, I will draw the tangent line in few parts of the graph. For example, at pi over 2, if I want to graph the tangent line at pi over 2 will be a horizontal line. Also, if I want to draw the tangent line in 3 pi over 2, it gives me another horizontal line. And if I draw the tangent line at pi, it gives me a line with the slope of -1. And if I draw the tangent line at 0, it gives me a line with the positive slope of 1. Now, what we do here, actually, let me graph, this function is f of x equal sine x. Let me graph f prime of x. It means all the slopes of the tangent line, I'll move it to another graph. Look how I'm moving all the tangent lines. At 3 pi over 2, the slope of the tangent line is -1. Let's mark here like 3 pi over 2. The slope is -1. At pi, the slope of the tangent line is at 3, I'm sorry. Let me correct this. At 3 pi over 2, the slope of the tangent line is 0. We know any horizontal line, the slope is 0. Okay, here. At pi, the slope is -1. At pi, the slope is -1 here. At pi over 2, the slope is again 0. And at 0, the slope is 1. Now, you see, if I connect these points like this, which graph is this? What do you think? The graph starts from 1, then it goes at pi over 2 to 0, then at pi, it goes to -1, at 3 pi over 2, it goes to 0. Which graph is this?
Cosine.
Those of you that you had a trig class, immediately you understand this is the graph of cosine x actually. You see, when I moved all the slopes of the tangent line to a next graph, I end up with the graph of cosine. It means the derivative if I have a function f of x equals sine x, d over dx, the derivative of sine x always gives you cosine x. You have to memorize this, number 1. Number 2, d over dx of cosine x. If you do the same process that I do for the sine for you, if you draw two graphs, you will see you will end up with negative sine x. It means the derivative of cosine x is always negative sine x. Now we have 6 trigonometric functions, but at least I know the 2 main ones, which is sine and cosine. Next, I'll show you the proof for the tangent. And after that proof, I'll just make a list of all 6 for you. Look, I'm looking right now for the derivative of the tangent x. What is the derivatives of the tangent x? If you remember from your trigonometric class, instead of tangent, we always can write sine over cosine. Basically, what I do here, I will look for the derivative of sine x over cosine x, because I know tangent means sine over cosine. And now, if you look this d dx of sine x over cosine x, which rule of derivative I should use to confine this derivative? Do I deal with the quotient rule here? Sine x over cosine x? For me, it's quotient rule. And remember, if you're looking for d over dx of f of x over g of x, it's always g f prime minus f g prime over g squared. I will apply that formula on this, my quotient rule. Then I can write d over dx of sine x over cosine x equals, I need a big fraction bar, g. G is my denominator. It means cosine x. d dx of f. F is sine x. Minus f. It means sine x. d dx of cosine x over g square. It means cosine square x. All of you, hopefully you know when you are squaring a trigonometric function, please do not write cosine x squared. No, it becomes cosine square x. Now, let's look for these derivatives. Then d over dx of sine x over cosine x equals cosine x times the derivative of sine x. We just proved the derivative of sine x as cosine x, minus keep sine x, and the derivative of cosine x as negative sine x, all over cosine square x. Simplify. D over dx of sine x over cosine x equals cosine x times cosine x gives you cosine squared x. Negative times negative gives you positive. Sine x times sine x gives you sine squared x over cosine squared x. You should remember from trigonometry, what is sine squared plus cosine squared? Your first identity in trigonometry, sine squared x plus cosine squared x becomes always what? 1 over cosine squared x. And also from trigonometry, we know 1 over cosine equals secant. Here I have 1 over cosine square x. It means I'll end up with secant square x. Now I can say that the derivative d over dx of sine x over cosine x, which is basically d over dx of tangent x, is equal to secant square x. You have to just remember this part, that d over dx, or the derivative of tangent x, always gives you what? Secant square x. Again, you are not required to learn the proof, but if you wish to practice at home, you can find the derivative of cotangent x, secant x, cosecant x this way. Now, what I'll do, I'll erase the board and I'll make a list of all trigonometric functions, all 6 with their derivatives. Let's start with sine again. Number 1. d over dx of sine x, the derivative of sine x gives you always cosine x. Number 2, d over dx of cosine x always gives you negative sine x. Number 3, d over dx of tangent x gives you always secant square x. Number 4, d over dx of secant x always gives you secant x tangent x. Number 5, d over dx of cosecant x always gives you negative cosecant x cotangent x. Number 6, d over dx of cotangent x always gives you negative cosecant square x. This table, you have to memorize it. When you are dealing with derivatives of trigonometric functions, or later, hopefully in chapter 4, when I start antiderivatives, which is integrals, you have to remember this. Because this table works two ways. When I introduce to you integral, you are going from right to left. Now we are talking about derivatives, we are going from left to right. This table is really important. Try to somehow memorize this table. Any question on this part of the lecture? Yes, no? Okay. Now, let's start with few examples and practice these formulas, correct? Example number 1. Differentiate y equals x squared sine x. Differentiate means find the first derivative of this function. It means find y prime. Remember, from now on, because you are at the beginning of derivatives, try to learn when you are looking to a problem, immediately think about which rule I have in this problem. Which kind of problem is this? Should I apply the addition rule? Should I apply the subtraction rule? Should I use the product rule? Should I use the quotient rule? Analyze your problem. You see, I have y equal x squared sine x. Actually, it's a product rule. X squared, I can name it f. Sine x, I can name it g. It means I'm dealing with the product. And my formula for product was d dx of f times g equals f prime g plus g prime f. That was my rule. I'll just apply this rule in this problem. Then I can write y prime equals f prime, or maybe on the, let me go that way. Sometimes I go opposite way. On the formulas, I give you this way, f g prime plus g f prime. Maybe I do this because it's addition. It doesn't matter which one you write first. It's basically the same, but because you have this, I'll follow this. Then y prime equals f. What is f? F means x squared. G prime, it means d over dx of sine x. Plus g, what is g? Sine x. Times f prime, it means d over dx of x squared. Now, y prime equals, keep the x squared. What is d over dx of sine x? We just created a table. The first derivative of sine x is cosine x. Plus, keep sine x, and d dx of x squared gives you 2x. You can keep your answer this way, or usually only this part, because we have sine x times 2x, and you know this, the first x, when you write sine x, it's not actually an x, it's your argument of the angle. We order it this way to avoid confusion. Y prime equals x squared cosine x plus put 2x first, then sine x. That will be your solution for this problem, the derivative of the given function. Any question on this problem? Yes, no? Okay. Let's do another example. Example number 2, f of x equals secant x over 1 plus tangent x. My first thing to do is to see which formula I can use. Besides that it's a trigonometric function, which rule I should use. And clearly I can see I'm dealing with the quotient rule. Then my quotient rule was d over dx of f over g equals gf prime minus f g prime over g squared. Let's apply the rule. Then I can write f prime x equals g, which is 1 plus tan x, times d over dx of secant x, minus f secant x times, d dx d over dx of denominator, which is 1 plus tan x, all over denominator square, 1 plus tan x square. My next step is to find those derivatives in the top. Then f prime x equals, keep 1 plus tan x, d over dx of secant x. I just give you a table. The derivative of secant x is secant x tan x minus, keep the secant x, and the derivative of, you have d over dx of 1 plus tan x. D over dx of 1 becomes 0, right? The derivative of a constant is 0. And d over dx of tan x gives you secant square x. Understand this part because I didn't write the 0? How I took the derivative of 1 plus tan x? The derivative of 1 is 0, and the derivative of tan x is secant square x. All over 1 plus tan x all square. Now, in the top, it's kind of algebra. I have to simplify it a little bit. In this chapter, you need to remember at least the main identities from trigonometry to can simplify some problems. Now look, f prime x equals. You see here I have secant x and I have secant x in this term, right? Because I see it as a two term. All of these, I see it as a one term. And all of this part, I see it another term. Secant x is common in this two term, in these two terms. Then I can factor out secant x. What left inside, in this term, tan and 1 plus tan x. This is what left here. Is it okay if I distribute also in this step the tan x to this parentheses? Look, I'm distributing tan x here. Tan x times 1 gives you tan x. Plus tan x times tan x gives you tan square x. Minus, you took secant x as a common, what left there? Secant square x. All over 1 plus tan x all square. Any question up to here, especially the last step that I did 2 steps together?
Yeah, I have a question.
Uh-huh.
How is the derivative of 1 plus tan x just secant squared x? What happened to the 1?
I'll show you now in the top, okay?
Okay.
Let me erase, I'll show that one, then I'll continue with the problem. I'll keep the last part of the problem, I'll erase the top for you. Let me show you there. I'm really happy when you are asking me all these questions. Please do ask a question if you don't understand what, because sometimes I'm thinking that we covered this part, but still you are new with this. Look, I have d over dx of 1 plus tan x, correct? Is this an addition, 1 plus tan x? Definitely it's addition. Then I can write this one as a d over dx of 1 plus d over dx of tan x. And at the day that we explained the rules of or laws of derivatives, I explained to you that the derivative of a constant, which is 1, is always 0. Plus the derivative of tan x we just proved today is secant square x, which gives you back secant square x. Understand now? Clear? Any other question? Okay, let's continue with the rest of the problem. Now, look at, I'll keep my secant x, f prime x equals secant x. Look at inside the parentheses, you have tan x plus tan square x minus secant square x. Excuse me again. I don't have corona, don't worry. I'm shouting too much, that's why I cough. And you are safe, you are on the other side of computer. Secant x times. I'll keep the tangent x. Instead of tan square x, if you remember again from trigonometry, I will rewrite here with a different color for you. Tan square x plus 1 is equal secant square x. This is an identity from trigonometric class, which is secant square x is equal tan square x plus 1. Now, if I solve this equation for tan, I will end up with tan square x equals secant square x minus 1. Now, what I do, I'll replace this tan square x with this value, secant square x in the top. It means here I will write plus secant square x minus 1 and minus secant square x over 1 plus tan x all squared. Any question in this step? How I substitute the value of tan square? I use trigonometry identity. Now look at your parentheses. Can you simplify it now a little bit? Then f prime x equals secant x times positive secant square x, negative secant square x cancels out each other. What left inside? Tan x minus 1 over 1 plus tan x all square. That's your final answer. Question for me. Please, if you have a question, ask me. I cannot see the chat at the same time because I turned my laptop to a kind of whiteboard here to write for you. Any question? Can I move to next example? Okay, I'm erasing now the board. Let's do another example. It's actually a physics example. It's really interesting. You have a spring somewhere like this. And an object is connected at the end of this spring like this, right? You are pushing down this object like this. You bring it to this position. We call this position the initial position. And when you push it down, you take it down, this is the new position. Usually, the position in physics, we use S to represent the position, correct? In your book, it's mentioned this object is moving down 4 centimeters and the position function is given to you as a S equal f of x equals 4 cosine t. This function is given to you in this problem, which is a position function in physics. Why t? Because you know when you're moving from one point to another point, time gets involved, right? It means in position function, you always have t there. Now, what they're asking you in this problem, they're asking you to find the velocity function and also find the acceleration function. Let me explain it this way because I taught physics for a few years, at least I know what is velocity, what is acceleration. When you are looking for the velocity, if the position function is given to you, your velocity is always the first derivative of position. Velocity is the first derivative of position. You see how I write the math? V equals ds over dt. The first derivative of position. Position is s, then the first derivative will be ds over dt. Acceleration is the first derivative of velocity or the second derivative of position. Correct? Acceleration is dv over dt, or you can say acceleration is equal d2s over dt. The second derivative of position or the first derivative of velocity. Don't worry at this problem at the second derivative because first you have to find the velocity. I will find the velocity, then I'll use the velocity to find the acceleration. Any question up to this step? Okay, now. First, I want to find the velocity function for this problem. I know v equals ds over dt. It means find the derivative of this given function. It means find d over dt of 4 cosine t. Then I can say v equals, you see I have again a constant, I'll bring it in front of the derivative. I can write 4d over dt of cosine t, which is v equals 4. What is the derivative of cosine? We just proved the derivative of cosine is negative sine t. Multiply the negative, v equals negative 4 sine t, the velocity function for this problem. Question? Now, I'm looking for acceleration. I'll erase the top part. As I explained to you, acceleration is the first derivative of velocity. It means a equals dv over dt. It means take the derivative of this part, this function that you just found. It means look for the d over dt of negative 4 sine t. Then a equals negative 4 d over dt of negative sine t. Or even you can move this negative. I moved it already. I don't know why I wrote again. Negative 4 sine t. Then a equals negative 4. What is the derivative of sine? Cosine t. This one will be the acceleration function for this problem, correct? Usually in colleges, when we teach physics based on calculus. Also, we have the same dynamic physics based on algebra, but most of the colleges, we teach our physics based on calculus. And at least you need calculus 1 to do very good in the physics class, because after this, you will see a lot of physics problems in your book, in your calculus book. Let's do another example. Before going to next example, any question here? Yes or no? Okay. Next example. Find the 27th derivatives of f of x equals cosine x. That 27th derivative. Do you want to go one by one up to 27? It takes 2 pages to find that. Let's use a technique here. At least I'll go from 1 to maybe 4, and after that we can take a decision. Look, I'll start with f prime, with the first derivative. F prime x equals the derivative of cosine x. We just learned today it's negative sine x. Now, f double prime x equals. F double prime means now take the derivative of this. Take the derivative of negative sine. It means find d over dx of negative sine x, which gives you negative d over dx of sine x, and d over dx of sine x is cosine x. It means you end up with negative cosine x. The third derivative, f triple, the third derivative of this function. It means find the derivative of negative cosine x, d over dx of negative cosine x. Again, you can pull out the negative. It will be negative d over dx of cosine x. And the derivative of cosine x is negative sine. It means negative sine x, which gives you positive sine x. The third derivative of this function becomes sine x. Let's look for the fourth derivative. After this, I will not draw 4 primes there. I'll just put a 4 here. And remember that 4 represents the fourth derivative. It doesn't mean f to the power of 4. The fourth derivative of this function, it means look for the fourth derivative of sine x. It means look for the derivative of sine x, d over dx of sine x, which gives you cosine x. Now I can see something here. After taking the derivative of the function f of x 4 times, I end up with the same thing. I end up back with cosine x. Can you see it? The given function is cosine x, and the fourth derivative is cosine x. Now, if you have a function f of x cosine x, and every multiple of 4, your function will come repeating. It means the 8th derivative of this function again becomes cosine x. The 12th derivative of this function is cosine x. The 16th derivative of this function is cosine x. And the 24th derivative of this function is cosine x. Now, using this method, because I know it's repeating after every 4, it's a multiple of 4, then I can write this. I can write the derivative, the 24th derivative of x equals again cosine x, because 24 is a multiple of 4. Now what I do, I'll go 3 more and it's easy to find the 27. Then the 25th derivative of x will be again negative sine x. The 26th derivative of x gives you negative cosine x. And the 27th derivative of x gives you positive sine x. Final answer. Any question? Any question on this problem? Okay. Just one more topic for this section that they covered also this limit for you, but I'm sure we did it in 2.2. The limit of sine theta over theta as theta approaching to 0 is 1. Please memorize this and I'll show you why. If I graph sine theta over theta, you will see a graph something like this, a curve like this. Based on the limit rules, as theta approaching to 0 from the right, or if theta approaches to 0 from the left, you know you cannot plug in 0 here in the denominator. It means you have a hole here. The value of this limit always becomes 1. Now, using this as a formula, you can simplify some of the limits of the trigonometric functions based on this rule. I'll erase this and I'll show you the first example, how I'm using this to actually find the limit of some trigonometric functions. Example number 1, find the limit of sine 7x over 4x as x approaching to 0. In your book, actually, this problem is written really in a difficult way. Maybe if you read the book, even you don't understand why. In your book says, first we multiply the given function by 7 over 7. The reason that we want to multiply by 7 over 7 because of this formula. Because I have sine theta over theta, as theta approaching to 0 is always give me 1. You see, whatever the argument is here, you have the same number in the denominator. The reason that we are multiplying this function by 7 over 7 is because I want to see the same argument that I have here for my angle here in the denominator. Then I can write the limit of sine 7x or 7 sine 7x over, instead of 7 times 4x, I can write 4 times 7x, which is the same, right? 4 times 7 or 7 times 4, it's the same thing as x approaching to 0. Now, you see here, I have a constant. I can pull it in front of the limit. Then I can write 7 over 4 limit of sine 7x over 7x. Now, if I name 7x theta, as theta approaching to 0, definitely x is approaching to 0. Then I can rewrite this one as a 7 over 4 limit sine theta, because I named 7x theta, over 7x, which means theta, as theta approaching to 0. And for this part, I have my formula. Sine theta over theta gives me 1. It means 7 over 4 times 1, which gives you 7 over 4. Any question? Yes, no? Last example. Find the limit of x cotangent x as x approaching to 0. Again, for you, you should remember this, that only I have the limit of sine theta over theta as theta is approaching to 0 gives me always 1. Here I have cotangent, even I don't have sine and cosine. Then my first step is to write cotangent in terms of sine and cosine. Then I can write limit x. Cotangent means cosine x over sine x, right? Then I'll replace cotangent as a cosine x over sine x as x approaching to 0. Next step, I want to go to this form, and I see in the denominator I have sine x. What I need, it should be sine x over x to actually match this formula. Then what I do, I'll divide the top, I'll divide the numerator by x, and also I divide my denominator by x. And you know, when you divide the numerator and denominator of a fraction, you are not actually changing the value. Nothing will change, correct? Now here x cancels out with x, and I'll end up with limit of cosine x over sine x over x as x approaching to 0. Now plug in the limit. The top becomes cosine 0, not theta 0. Denominator, limit of sine x over x is always what? 1. Now, what is cosine of 0? Cosine of 0 is 1. 1 over 1, then your answer is 1. Correct? That was the last example in 3.3. And 3.3 was about derivative of trigonometric function and also some limits. Now, if you have a question for me, please ask. Any question? Yes, no? Okay, Monday, I will cover for you maybe 2 sections, 3.4 and 3.5, but before that, definitely you will receive video lectures for those 2 parts and also presentation in your Canvas. Question? How much time we have? Like 10, 15 minutes? It's actually a good turnout, like 20 people is showing up. I know I have to post also my recordings from this Zoom meeting, but it's not my mistake. Even the lecture that we had last week, even I don't receive that one yet. They have to send me the video and they didn't send yet. As soon as I receive these videos back, I'll post these Zoom meetings also on the Canvas. No question?
Professor, I have a question.
Uh-huh.
Can I still take the quiz, or is the quiz still able to be taken?
Is this closed or open? Because I put like 3 days for the test, right?
No, the quiz.
Oh, your quiz, yes.
Yeah. Okay.
Send me an email, Robert, please. I'll send you. Which quiz you missed? Quiz number 1 or 2?
I think it's the first one you put on Canvas, not the one in class. There's like a 5-question quiz.
Quiz is only in class.
Oh, okay.
I didn't put yet any on Canvas.
Oh, okay. Because I saw it. It's like under. It's not under quiz. It's like under like assignments or something. It's a 5-question quiz.
A 5-question quiz that was it's empty actually. The only way that I should transfer your quiz 1, the grades of quiz 1 to Canvas that you can see after this is to create a quiz.
Okay.
Actually, that quiz is done. You had it in the class. And also you had another one with me in the class.
All
right. Another question in the chat, is the homework past due? This time for this test, even today is not a past due. If you have it, please send it. I'll give you full credit. But for test 2, you have to submit on the test day. Only for this one, you can still submit that one. Any other question?
Did you cover 3.2?
We covered 3.2 and this is also 3.3 today. Today I covered 3.3. Any other question? No? Okay, then I'll end up our meeting for today. Be safe out there. Listen to me, listen to everyone. Please do not go out. Your safety is really, really important. Stay home, be safe. and see you Monday. See you Friday. If not Friday, Monday. Today is Friday. You see, I lost the days because every day I'm home. I don't know which day is today. Today is Friday. See you Monday at 9.
Thank you.
Thank you,
You're
Professor.
welcome. You're welcome.